Let's get this thing rolling.
So can it actually like hear us?
Yeah. Yeah, if you've heard, actually, because I know Zach was asking some good questions when I was listening to one about surface areas and stuff.
Did you get me saying
Don't, thank you, Zach, for stopping yourself.
I think every sentence now is going to swear. Say one swear word.
You're interrupting. 4.2, some problems with triangles. Now this is more of the same. And for some of yous, if you haven't been here for this, you got a lot of catching up.
Oh yeah, I know how to do this.
You're not supposed to do that. You're not supposed to point kids out like that.
Okay. Now, how do we do this? Solving x and y. You got two right triangles, and I know they're right triangles because they have these little squares in there, meaning that's 90 degrees. Don't try to solve it all at once. Try to find out which one is the best to do first. And I'd say the top one is. So I'm going to just trace it and redraw it over here. So I'll undo that. Lock that puppy down. Now, we're going to just solve this triangle right now. And that's 6.4 meters, 40 degrees, and side x is what we want. Now, look on the side, or if you have your other sheets, sine, cosine, and tangent. As far as 40 degrees is concerned, 6.4 is what? The opposite, the hypotenuse, or the adjacent? It's the adjacent, thank you. So, this is my adjacent side, and the x is the hypotenuse because it's across from the right angle. Great news. So this is the hypotenuse. So what you got to do is you got to look. Okay, what's that? I'll go through some of the other sections with you, actually, after you do online, and it'll make a lot more sense. Adjacent means beside. Hypotenuse is across from the right angle. Now you've got to find out which trig function has both adjacent and hypotenuse. He knows the stuff. Cosine, right off the bat. So, what I'm going to put down is the cosine of 40 degrees is equal to adjacent side over hypotenuse. Then, on your calculators, get them revved up. Make sure that they're in the DEG mode degrees. And you'll know right away because you'll get the same answer as I do, so double check.
0.76. So I got.
Well, I'm going to see. I don't know. I don't have these memorized. Cosine of 40. 0.766. Let's keep 3 digits usually, eh? 0.766. You were right, young man. So 0.766. I'm going to make this out of 1 so it looks like a fraction. Is equal to. Now, from the diagram, I'm going to replace adjacent with 6.4, because that's what we labeled as our adjacent side, right? And the letter x instead of hypotenuse. Once you have this, the world is not your oyster, but it's something that's pretty good. Cross multiply, divide by the lower. 6.4 times 1, divide by 0.766. Good. 8.355, let's round it to 8.4 centimeters then. And the reason why I chose that is because, you know, this was 6.4, only 1 decimal place behind. Let's go to 8.4. So, x is equal to 8.4. That's from the 8.355. Is that meters or centimeters? I think that's meters. It is. So, that's only the first triangle. We've done that. But now we can use that side to help us with the other triangle. So what I'm going to do now, I need a different color. Is take a look at the long, narrow triangle that's sort of underneath and to the left. And what is that? 68 degrees. the letter Y. Oh, no, it's Y. And I already know that from the other answer that X is 8.4 meters. So I don't need to call it X anymore, but that's where it's from. It's from I'm using the original color so you know where that came from. Okay. Now with this one, 68 degrees and X. X is opposite. So you figure out, first of all, what your sides are. That's an opposite side. And the word adjacent means beside. And connected also, though, it has to be connected to the right angle to be adjacent. Because you could say, well, this hypotenuse is connected. Why isn't it adjacent? Hypotenuse is always across from the right angle, so it can't be an adjacent side. So this is the adjacent side. You say, which two, or not which two, opposite and adjacent, they're related by the tan function, tangent of 68 degrees in this case. So the tangent of 68 degrees opposite over adjacent sides. And I'm actually asking you guys to actually write out each step like this and then do the decimal step. Type that in. I'll wait for a second and then put in your other side. I'm going to wait for you guys to put in your other side as well. Sure, yeah. I heard 2.4.
2.4.
Excellent. Now I'm going to make that out of 1 so that we know how to solve this equation. The other side, instead of adjacent, I'm going to use the letter Y on the top and use 8.4. Previous answer. You couldn't have jumped to letter Y, what we're doing in green, first. There's no way you could, because you didn't know. Initially, you didn't know this side, right? Until you solved the first triangle. So, cross multiply 8.4 times 1, divide by 2.4, 7.5. Braden, you have an answer, don't you?
What?
You have an answer.
Yeah.
Yeah, I know you do.
Oh, you want me to give you an answer?
Sure.
You get it. 3.4.
3.4 it is, man. Kids on fire today. There's your two answers for X and then and Y. Okay, what's that? Nope. All we were asked to do is find the value of X, find the value of Y. So we don't need a perimeter of the whole triangle or anything in this case. Sometimes in a word problem you might be asked to. Yeah. But that's what we were asked to find. And the whole idea is that decide which triangle you can do first, and then which triangle you have to do second, you know. So that's, if you had done the first section, it'd be really a lot easier for you, Zach. I can tell you're catching on already. I'll do one more problem with you guys and then turn you loose. Whether you need to do 4.1 as well. Now this one's got about kind of 4 parts to it. Let's draw it together. Flagport supported by 2 guy wires. Each is attached to a peg in the ground 4 meters from the base of the pole. The guy wires have angles of elevation of 35 and 45 degrees. Now, there's your flag. There we go. Maple leaf, whatever. Anyways, that doesn't, the flag pole itself doesn't matter if you have details on it. I just thought I'd put that there. Now, the guy wires have angles of 35 and 45 degrees. It doesn't matter how you draw it, but the base has to be the same, 4 meters from the ground for each. So I'm going to draw one triangle like this. Call this 4 meters. Listen, That's about 45 degrees-ish.
That's the 45 degrees.
Well, it says one of them is, and one's 35.
So it's
Now I'm drawing a picture right here. Right? Two triangles. I guess they're both right triangles, so I'll put this in here. This in here. Now we'll talk about this a little bit. The trick to a word problem is getting a diagram out of it for this though. I think once you have the diagram, it's way easier. So, from reading that, do you think you could have, like, is this exactly what you'd see necessarily if I said there's two guy wires attached to a flagpole? I'd say no, probably this isn't. The, say this right here, that might be like more facing you from inside the board, like more coming out at you, like this direction. You know, like out, I can't draw in 3D, right? Or maybe behind. Like they may be set up 90 degrees to each other. If I said, like this is a bird's eye view of the pole, the one might be out here, and the other might be sideways to it, right? Or they could even be, I don't think it would ever be like this because, well, it could be. You could have one like this, then the other like this. It doesn't matter, and it didn't say, like, you know what I mean? You could have the two guy wires. You've seen wires like that before too, from one point in the ground, going up. All of those scenarios work with this. You'll still get the same answer. How much higher up the flagpole is this top wire than the other? That's still the same distance. Whether this is flipped around and onto this side, I didn't need to do that. But if that's on there, it's still the same distance. So if you're hung up on like, well, they didn't tell me that they're exactly opposite each other, it doesn't matter where they'd be put. The two triangles are going to be the same. Whether they overlap each other, or 90 degrees to each other, whatever. And the length of the wires for part B is still going to be the same. Now, I consider this two problems at once. I'm going to move mine sideways a little bit. So, for part A, how much higher is the top guy wire attached? So our green is the one we drew that'll be higher, right? Well, I didn't put 45 degrees down. And then blue is 35 degrees there. Well, I'm going to consider it two problems. I'm going to have the 45 degree problem. I'm going to draw that right here. This is 4 meters. This is 45 degrees. We want to find this height. And likewise, the other one is shorter. This is 35 and this is 4. What is this height? I'm going to work in the green one first. But do people see? I just took the two triangles and separated them, right? This is our diagram separating. So, the old green devil here. 4 to 45 is like the adjacent side. X is like the opposite side. If you recall from the previous problem, tangent, 45 degrees, is going to be our opposite and adjacent here. And we'll replace those. Now, don't think your calculator screws up when you do tangent of 45. You'll get a really simple number. Trust it. It's what it is. And what'd you get? 1?
I got 7.37.
Tan 45. Yeah, I know. Okay. 1 out of 1 is equal to the opposite over adjacent. Well, the opposite is x out of 4. This one you should be able to do in your head now. 4 times 1, divide by the loner. Divide by 1 is still 4. Now that's the only time you get a triangle that's that easy. The reason being is, 45 degrees cuts a square perfectly in half. So doesn't it make sense that if you had a square, okay, I didn't draw it quite right, that, if this side of the square was 4 meters, this side of the square would also be 4 meters. That's why 45 degrees works that way. Now it's all going to dissolve there. So don't think that tangent works that way always, only with 45 degrees. The other one, though, the tangent of 35 is opposite over adjacent as well. That one type in and you will get some crazy decimal. 819, as a matter of fact. Opposite of 35 is the letter Y, and the number 4 is your adjacent side. You multiply that, 4 times 819. Oh, good gravy here.
Yeah, you did that wrong.
I did that wrong. Yeah.
700.
Thank you, man, because I'm just saying. Good gravy. Did I do the other one right? Yep, opposite over adjacent. But here, this one, opposite. Anyways, where am I?
Wait, it's not opposite over.
What am I talking about, man? It's not the, yeah. My mistake here altogether. Opposite over adjacent. It's not 819 though. I gotta type it in, 0.7. Okay, anyways. That's my mistake. That's why I'm getting confused. Hit the wrong button, didn't I? I hit the cosine instead of the sine, I think. 0.700, right? Thank you, little buddy. Opposite is y over 4. 4 times decimal 7, 2.8 meters. Now, that doesn't entirely answer the question, does it? A, how much higher is the flagpole, up the flagpole as the top wire? How would you find the difference? Subtract. 4 minus 2.8 gives you the answer you want. So, height difference. Which is 1.2 meters. That answers A. Then, how long is each wire? That's just solving the green triangle for the hypotenuse and then solving the blue triangle for the hypotenuse. Separate incidents. I think you already are catching on to this, right? A little bit? No? Okay. Well, here. Yeah, how do we do B? Oh, I'm going to do that. Okay, I'll lock this on so I don't move it again accidentally. Okay. All I'm going to do here is grab off. Why is this all? Let me just see about something here. Flip back. Oh, it's all gone. Screw you. There we go. Clone that. Toss it down. Clone that. Okay, reason being is because I'll use the same diagrams in B, but how long is each wire? That means we need the hypotenuse on each one. The green hypotenuse, the blue hypotenuse. And on these triangles here, I'll do the old green here. What is it, B? So, we got adjacent and hypotenuse. That's cosine.
Wait, what is it called? Hypotenuse?
Hypotenuse is the side opposite the right triangle. You've used that before. The a squared plus b squared equals the side opposite the hypotenuse, c squared, or side opposite the right angle. and that's called the hypotenuse. C squared, and you remember you've used that before. Anyways, adjacent hypotenuse. 45's cosine is 0.707. You type that in. Come out with 707 over 1. The adjacent side is the number 4. Hypotenuse is what we're trying to find. So then you do cross multiply. 4 times 1. Divide by the loaner, divide by 0.707. H is equal to, so the height of that triangle is equal to 5 point, or not the height, the hypotenuse is equal to 5.7 meters. That's the length of the wire. I'll wait for a minute and let you guys guide me through and show me how you can get this one to be 4.9. So I told you the answer. Tell me how I get it. While I'm doing that, I'm going to pause the recording.